All right, guys, it's that time again. I am back to talk about solving an equation that involves fractions. Okay, so this is something that we went over in class the other day. Now, when we are talking about solving an equation with fractions, that's typically going to be where there are fractional coefficients which can be eliminated to make solving easier using the least common multiple, or also known as the LCM. Now, the first thing that we need to be concerned with is we need to examine the fractional coefficients. Those are the numbers that are attached to your variables, and determine if they are fractions, if they are like fractions, I should say. Now, an example of like fractions, of course, as we know, would be where 3/4 and 1/4 are like because they have the same denominator. And then 3/7 are would not be like with 2/9. Okay? Now, if the fractions are not like, we're going to use LCM to make whole number coefficients, and I'll go through that in just a second. We're also going to multiply each expression by the LCM using the distributive property, again, which I will show. And then once whole number coefficients have been created, we're going to solve the equation as normal. Again, something that we will go through in this video. So at this point, let's go ahead and take a look here. So the equation that we're going to be looking at solving will be the one that's listed there as 7/10 n plus 3/2 will be equal to 3/5 n plus 2. That'll be one of them. And then we'll look at a simpler one, which we're actually going to take a look at first with like fractions. So the one that we're going to be dealing with that does not have like fractions, which is going to be a little bit more in depth, will be the one that's listed there under example 1. And then again, we're going to look at one simple first that has like fractions. Okay, so if we notice here, we have the equation 2/11 m plus 16 is equal to 4 plus 6/11 m. So if we notice there, we have like fractions because they have the same denominator here. So at this point, do I need to use LCM? Probably not. Okay, as always, I'm going to draw myself a line to separate what's on this side of the equation as opposed to what's on that side. Now, as I tell my students, I need to move the coefficient and the variable such that I want to keep a positive, just for ease, I want to keep a positive coefficient. So my decision is going to be for me to move 2/11 m to that side, and what I'm going to do again is subtract 2/11 m. This is like creating a coefficient variable, for lack of a better way to say it, zero pair. Because if I have a positive 2/11 m and a negative 2/11 m, that's going to be 0. I'm going to bring 16 down here. I'm going to also subtract 2/11 m from that side. This is going to give me 4/11 m. Okay, when I have 4/11 m, that is going to be, it's going to have a positive coefficient. We want to keep that positive coefficient because we want to make sure that we have something that's a little bit easier to work with. Okay, so at this point, 4/11 m, and we can't forget our 4 here that we're going to bring down. Now again, I want to get the variable and the coefficient by itself. So what do? I'm going to use the same old procedures that we would use for any equation, which means that I'm going to isolate the coefficient and the variable by subtracting 4, in this case, from each side. This becomes 12 is going to be equal to 4/11 over m. Okay. Now again, we see that this is being multiplied. So in essence, what I'm going to do is I'm going to divide the coefficient. Now, when dividing fractions, as you know, we will use the reciprocal. So what I'm going to do is I'm going to multiply each side by 11 over 4 by 11 over 4. Okay? So in this particular case, what is going to happen is that, again, these will cancel each other out. When those cancel each other out, we'll just have an m left over, okay? When we have our m left over, we know as well that I have to do the same thing to the other side. So what I'm going to do is I'm going to multiply 11/4 times 12. And we know that this also means 12 over 1. And when I have a fraction, okay, I'm going to multiply across. So I know that 12 times 11 is going to give me 132 over 4, because again, remember, 12 is equal to 12 over 1, okay? 132 over 4 would then equate to the number 33, okay? M is equal to 33. Now, the way that I do my check in this particular case, as always, is I want to make sure that I plug everything into the original equation. So I'm going to multiply 12 11s because, again, we have 2 11s, not 12 11s, but 2 11s, sorry. 2 11s is going to be multiplied by 33, and the way that I get it to look like something that I would recognize is I put 33 over 1. We know that that is equal. I'm going to set everything up again. I am setting this up as 4 plus 6 over 11 times what my equation said that this was. I want to go ahead and try to cross simplify if I can. 11 divided by 11 is going to be 1. A common multiple of 33 is 11. Okay, so this becomes 3 actually, sorry. I'm going to do the exact same thing over here. So now when it's time for me to move this down, this becomes 6 over 1, or I'm just going to write 6. 6 over 1, remember, is 6. 6 plus 16 is equal to 4 plus, and that becomes 18 because 6 times 3 is 18. 18 over 1 is just 18. So 6 plus 16 is going to give me 22. 22 is also what I get from over here. So is that correct? Yes, it is. Okay. Now, moving things up. Now I'm going to be dealing with a fraction that is not like. Okay, so this one is going to require just a bit more work. First thing that I want to do is I want to come up with my least common multiples. Now, when I think of least common multiples, what I need to be thinking of, sorry, hang on. Okay, what I need to be thinking of for least common multiple would be the thing, think about your multiplication facts, okay? I know that 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15, so on and so forth, okay? I'm going to do a couple of those out. 10 times 1, 10. 10 times 2, that's what your least common, or your multiples would be, okay? Now, when I think about least common multiple, just as it says, I want the least number that they have in common. And the reason I'm using 5 and 10 is because of the denominators, by the way. Okay, I want to remind you. So my least common multiple is actually going to be 10. So what I'm going to do is I'm going to get this same equation here, okay? And I'm going to multiply both expressions, okay? When I say expression, I mean this right here on either side of the equal sign, because an expression is going to be normally numbers and variables separated by an operator. An operator will be plus or minus multiplication or division, okay? So I'm going to multiply each side times 10, since that was my least common multiple. I'm going to use the distributive property, as you saw at the beginning of the video, to distribute this to each of the terms inside, okay? So I'm going to show you what it becomes. This becomes 10 over 10 times 7 over 10 times n plus 30 over 2, okay? I'm multiplying 10 times 3 and 1 times 2. Again, I am multiplying this number times that fraction, 30 over 5 times n plus 2, okay? I'm going to just keep simplifying down, Okay, and I think that made a mistake, sorry, okay? I'm looking up at the screen and looking down, and I forgot my number. Anyway, 10 times 2, as we know, is not 2, but 20, okay? my mistake, sorry. All right, so 70 over 10 is going to simplify to 7n, okay? 30 over 2 is going to simplify to 15. 30 over 5 is going to simplify to 6 because 30 divided by 5 is 6. This becomes 6n plus 20. Now, this looks like something at this point that we can actually simplify. If you look back at my video with about simplifying or evaluating equations with variables on both sides, this is all that is now. I just got rid of the fractions because I don't want to deal with them. Sometimes they can be a little scary. So I want to do this. So remember, when I am deciding which side to move my variables to, I want to still create or have a positive variable, okay? And do not leave your variables behind. Remember, do not just write -6 or -6 over here, -6. You're going to get them confused with the constants. Always take your variables with you. Do not get accused of variable abandonment, okay? So 7n minus 6n, what does that become? It's just 1n, or also known as n. We typically don't say 1n, but just n, okay? That becomes this. Remember, this created 0 pairs there, okay? 0 variable pairs. So now I'm going to continue to make sure that n is by itself. I need to do one thing to this side and the same thing to the other. So this becomes n is equal to what? N is equal to 5. Now, I want to do a check much in the same way that I would do any check. Okay, I want to move this up a bit. Sorry. Now, I'm simply going to take the original equation. This is my check. I'm going to take the original equation, and I'm going to just substitute in everything that I see there. And when I substitute those things in, I want to make sure that I have the proper answer. Okay, so 7/10 n plus 3 over 2 is equal to 3/5 n plus 2. Okay, so I'm just going to start plugging in. I'm going to do 7/10 times 5 over 1, because remember, any whole number can be made into a fraction by putting it over 1. This becomes 3/5 times 5 over 1 plus 2. Okay. What I want to do is I just want to go ahead and multiply these fractions. Okay, that's 35 over 10. Now, what I can do is I can go ahead and put this into like terms. I know to create a like fraction, I'm simply going to multiply this number by something to get that denominator. So whatever I do to the top, I must do to the bottom. So 3 halves is going to be equivalent to 15/10. Okay. When I multiply that across, that becomes 15 over 5 plus 2. All that I'm doing is I am boiling down. I'm boiling down. It's keep simplifying. 50 over 10, because when I add fractions, I add across. Okay? And 15 over 5 boils down to 3. 50 over 10. One little trick here, when you have ending zeros, the way that I can get rid of those, they cancel each other out. 5 over 1 becomes 5. 3 plus 2 is 5. So I have a positive check. All right, so I have gotten to the end of my video, okay? If you were unclear about what I did, please watch this video again. I want the likes and I want the views. If you still have a question, come to class with a pertinent question. If you still have a question in class that you did not get answered, come to tutorials on Tuesdays and Thursdays. And as always, I will see you tomorrow in class.